Everything in the house is connected to one line, wastewater. So everything that you're running inside the house, sinks, tubs, toilets, washing machines, even your water softener, recharge, that's all going to go through the main line and be directed and travel to the septic tank. No different than if you're living on public sewer. Everything's the same on a house on public sewer. Everything comes through one pipe, but the difference is in a sewer system, it drops into the city sewer and continues moving to eventually end up in a sewage treatment plant. When you have a septic system, those flows are going to go to and end in a septic tank. I said end, they don't really end, water continues on, but your solids are going to end inside your septic tank. Inside that septic tank are baffles. Consider a baffle a shield. So your inlet pipe bringing the waste from the house comes into the tank, and there's going to be a shield in front of it. Sometimes they're plastic, sometimes they're concrete. And the idea is that shield, that flow comes in, hits the shield. You can never see you're not supposed to see the pipe from looking inside the lid, because you'll see the baffle. That baffle goes down into the center of the tank. So flow comes in, hits, and is displaced into the center of the tank. The light stuff floats, heavy stuff sinks, and then you have your partially clarified water that's moving through the center of the tank, which disperses up the outlet baffle, through the outlet pipe, out to the absorption area. So the most important parts of your septic tank are the baffles. The baffles control, stop, I should be going this way, stop and hold those solids. Floating solids can't exit the pipe because there's a shield around it keeping them stable. And then of course the sludge is on the bottom. Clear water out into the field. So as the water leaves the septic tank, we're holding all the solids back. We use 100 gallons of water. 100 gallons of water and waste goes into the tank, and slowly 100 gallons of water disperses out to the absorption area. It's going to travel through the outlet pipe to some type of distribution point. We're getting into the different types of absorption areas. Commonly, if you have in-ground trenches, you'll have a distribution box. Almost 99% of the time, you'll have a distribution box. It's a small concrete box. Pipe comes from the septic tank. Water falls into this tiny little box. They're about 16 inches by 12, give or take. Some are larger, some are smaller. And the idea is that it breaks out evenly into multiple trenches. So the water falls into that box and then out to each individual trench. Now, some drain beds have distribution boxes, and a drain bed would be a big rectangle, like the property we're on here today. That's a 36 foot by 20 foot big rectangle, one big trench, and that water goes through what we call manifold. So it's hitting a T, breaking out, running the perimeter, and that's got cross lines in the middle to evenly distribute throughout that entire bed. It's not an exact science, but that's the idea. In trenches, it's individual. Each trench, let's say this is a 3-bedroom home. More than likely, there would be 3 trenches if it had 3 bedrooms. And then each trench would handle about 133.33 gallons, something like that. Evenly broken up, each trench then absorbs the water. In a drain bed, it goes out into the entire bed and absorbs the water. And then we can talk about the other systems later. But the idea is that water comes through that pipe, perforated pipe, dribbles through the 12 inches of stone, and hits the absorbing soil. Depending on how much water you're using or the type of soil that's there, the reason why we have that 12 inches of stone aggregate is so that water can actually build. It gives time to collect and accept the water. And then as we stop using water, it slowly starts to absorb into the ground. Most of your absorption comes overnight when we're sleeping. Generally about 12 hours worth of not using water. It's absorbing all the time, if it's working. The soil that's underneath, like in this giant rectangle, the soil that's underneath that acts as a filter. So as the water leaves the stone into the soil, it's slowly going into the soil, down below the stone aggregate. The soil actually picks out the impurities of what we call the gray water or effluent water. So by the time that water reaches the water table, wherever it is, and we're hoping that it's further down, because the further down it is, the cleaner that water becomes, because it's being purified longer. But by the time that our effluent water that we're using hits the water table, we're hoping it's as clean as possible. And basically we start the process again. You turn on a faucet, the well turns on, it draws water from that water table, comes up into the house, you use water, you create wastewater, the wastewater goes out, the process repeats, drains down into the ground, a never-ending cycle. And the one thing that people have to realize is, you know, septic system absorption areas don't necessarily last forever. I mean, there's a possibility that some out there will, but generally they don't. And the reason being is that soil filter is much like an air filter in your car. At some point, that air filter has done its job to the point where it will no longer let any more air in. The nice thing about a car is you pop the hood open up the air filter holder, replace the air filter, close it, you're good to go. You can't do that with an absorption area. You'd actually have to pick a different part of the property and start the soils probes, percolation, test, and design to create the new soil filter absorption area.